All right, we have this graph here. You're more welcome to take a picture of this if you cannot see it. And if you need to move your chair to move up a little bit to see it, that's fine. Yeah. So this is how do we analyze the graph. How do we analyze a graph? Graphically. Okay? Okay. So first, before I go over that, I'll give you some like a warm up, lesson, so that way you can see it. So I'll give you some situation, simple like this. So first, it's gonna be like a open circle, a dot, a open circle going this way, and this is 2, and this is 7, I believe, if I can count. 5, and this is whatever. Okay, so first understanding, if limits x approach 2 from the left of f of x, from the left of f of x, so what do you guys think that if I approach 2 from the left is? Anybody want to raise your hand? Yes? No, it's not 5. Okay, so you obviously don't know what this means. So this, like a superscript, like an exponent, but it's not exponent. That means approaching 2 from the left. Now, if I'm approaching 2 from the left, I'm looking 2 and coming from the left this way. My output is what?
2 and 3.
It's going to be 3. Is that okay? How about limits x approach 2 from the right?
Is it the same?
7. Good, because you're approaching this way. Go into the 7. Alan, do you understand? Okay, so let me ask last question. How about limits x approach 2?
There's no limit.
It's not no limit, it does not exist.
Oh.
It's D and E. Do not exist. Okay, so why? Because left does not equal to right. Now, my last question. What is f of 2?
F2 is 5.
F2 is 5. How do you find out that it's 5?
Because x equals 2, you go up 5.
Yeah. So this is the y value of 5. You're looking for y value. Now, sometimes I ask this question first. If I ask a question, you must think about those 2 questions. Because if they come out the same value, then it's going to give you a value. If they come out different value, limit does not exist. Got it? So if you see this 2, right? 2 is not from left and right. If I ask you this question first, then you always look at that value from the left and right. Make sure they come into the same number, otherwise does not exist. So this is a general 2. This is not left of 2 or right of 2. So that means you have to look from the both ends. Got it? And this from the left, which is the closest thing here, you look for this region, closest region from the left is going this way, that's equal to 3. Or closest region from the 2 from the right is going to be this part, not here, but here, like closest region. So it's going to go here. Okay, that's going to be value 7. So here I want you to try this question. And a lot of questions are a little bit tricky. And we're going to go through them all. So this is understanding graphically. So yesterday we started with numerically. Today we're gonna go graphically.
On the limit thing, does it have to have positive and negative to know which side it's from?
Yeah.
So if it
It's the superscript on the right hand side, like an exponent, that's gonna tell you left or right.
but if it doesn't have it, then it's
Yeah. Tony, you can move your seat if you want. Move up there. A lot of seat up there. Okay. I'm gonna start with the first one. I'm gonna call on you guys, see what you think. Number one, when limit x approaches -1 from the left of f of x, Elaine, what do you think? 2 is good. -1 from the left side, which is this one. And that answer is 2. Is anybody confused? Everybody's confused? Good? Okay. Now number 2. When limit x approach -1 from the positive side, Chase. 4 is perfect. Now, I'm skipping a question. I'm gonna say, hey, what's limit x approaching -1? I'm asking you question 4. Catherine? Does not exist. Good job, because they not equal the same value. This 2, this is a 4, they come in 2 different results, therefore it does not exist. Is that okay? Okay. Jack, what's f of -1? -1 is perfect. You have to be confident. So -1. Like, whether right or wrong, I think you guys should be confident. Like, be very like I don't know. I don't like a lot of Republican candidate. I don't like them, but I do admire the ability to say whatever they say inside their head and very confidently. I do. I like Swami. I mean, that guy is very extreme, but look, he just say confident. What do you want to say? Whether it's Trump or things. Now, don't judge on me about things. I don't like those people, but and if you like them, great. If you don't like them, but I'm very admire their quality is just say what they think. At least that's how I am. That's a good quality to have. I think that's why it's attracting so much um, people. So, but regardless, I think that's a good quality. Okay, so 5, limit x approach to 1 of f of x. Maddie, what do you think? You put 2, okay. Tony, what do you think? 5. One, okay. Catherine? Does not exist. Catherine's right again. Does not exist. Tony, do you know why though? Yeah, approaching for both sides. If I have a general number like here 1, that means you had to look from the both ends, and that'll be does not exist. But it's okay if you got it wrong. At least Tony says, my answer is 2, and it's all right. And long as you stand corrected and everything's fine. Like I think it's fine, at least. Okay. Elaine, f of 1. Number 6. Huh? F of 1. Nope, it's not 1. Madeline? Huh? 2 is good. 2 is a good answer. Because of the solid dot. We're not looking at the limit. If the limit does not exist at 1, approaching 1, it does not exist. Because from the left it's 2, from the right it's 1. But f of 1 is basically looking for the circle that's dotted. That's a black circle, which is right here. Does that make sense? Because there's no basically f of 1 is looking for evaluations. Does that make sense? Okay. 7. Avadesh? No, it's a -4 from the left side.
Approaching infinity.
Do what?
It's approaching infinity.
Infinity is good. Now, a lot of people didn't understand that, but this is a 4. This is a -4. If approaching this way, yeah, that's definitely a positive infinity because this is an asymptote. A dotted line means asymptote. This going to a positive infinity. Now, some people can put that does not exist. That's understandable, but just if it goes up like this case, either answer is fine, but I prefer positive infinity. Because this is actually unbounded behavior. And so you can say it does not exist, but it's going to positive infinity. Okay, so 8, limit x approach -4 of f of x. Chase? Does not exist is good choice. Because if you look at it from the right and the left, one's positive infinity, one is negative infinity. So therefore does not exist. Okay. Limit x approach -3. Ding.
It's not exist.
Jack. Aiden.
0.
0 is good. It's not -2 because -3 is right here. Because we are not asking for evaluation, we're asking limit. So we lessen how we approach it. If we approach here from both ends, that's going to give you 0. So therefore the answer is 0. Min, does that make sense?
Yes.
Okay. What's f of 5, Min?
I got 1.
F of 5 is 1. That's for oh, f of 5 is not 1. Ethan? What do you think?
It doesn't exist, right?
Does not exist. Yeah, I thought it was solid that for a second. Because it's not filled in. If it's filled in, now limit x approach to 5 is 1. But f of 5 is not defined because there's no black dot. So f of something, you're looking for a black dot,
Okay.
pretty much. Limit x approach to 5, Corbin?
You said approaching 5?
Yeah. Just 5, a single number. It's not from the left or right.
Would it be 1.5?
No. Madeline? You think it's 1? 1 is good. Say confidently. 1. It doesn't matter you're wrong or right. The only matter when wrong or right is on the test dates. On the test. Right? So right now you should confident on what your answer and you should believe it. You know. Like I say, that's one thing I admire all the candidates here. Well, all the politicians are pretty like that. I like it. Yeah.
So if 9 and 11, we can both answer it and use it the same.
Yeah, for number 9 is -3. So you reach here, that's gonna give you 0. For number 11, reach 5, they are reaching here, that's 1. But they're not asking f of 5. F of 5 will be undefined. Okay. So how about the last one? Josh, what do you think last one? Limit x approach to -infinity.
I got 1.
1's perfect. Do you guys understand why it's 1? Because there was an asymptote. It's going toward a plateau, and this plateau down to 1. Because it go into like this.
What was the last question?
Last question is right here. Limit x approach to -infinity. -infinity. Sorry, it's kind of small. But it's a -infinity. You're gonna approach this way, and that's going to go plateau into 1, and that's it. Yes.
So if it's like f of x, you're looking for a black dot.
Yes, you're looking for a evaluation. Limit x approaching something, you're looking from both ends. Limit approaching a number from the right side, then you're looking from the right side what it goes to. And limit approaching the left side, you're watching from the left side. You see what it goes to. Now, if they both are not matching, so the limit goes to that number, it does not exist. So any question that you think you're confused about?
Wait, how do you look at it when it's asking you x approaches -infinity?
-infinity, good question. So if it's -infinity, it's going this way. See that this is asymptote?
Yes.
So the value eventually is going to turn out to be 1. Because if you go to infinity, they're going to go close to 1. Does that make sense? So this is the easy part of the test. Okay, so what?
Nothing.
What'd you say? I'll fight him.
Yeah, same.
I will be split. Anything.
When's
My money
cook-off
on you.
between you and Luke gonna be?
Huh?
Oh, I want to be there. When's the cook-off gonna be?
Me and Luke?
Yeah.
You're gonna lose. You're vegetarian.
Huh?
You're gonna lose.
I can cook vegetarian better than he can cook me.
Wow.
You can say cook. That's gonna be posting. They're making cook. You see, food dog.
Huh?
Food dog. He's vegetarian. Mr. Yeah, you eat tofu?
Yeah. I'm not vegan. I'm a vegetarian. I'm vegetarian all my life. I never eat meat my entire life.
Oh, if you eat it
Huh?
now, you eat it now, it's probably kill you.
It won't kill me, but
You'd be sick. You'd be really sick.
no, it would throw up, but that won't kill me. But
Eat fish.
Ethan says hi. I don't eat fish. Fish, that's pescatarian.
Yeah.
Okay, so limit x approaches C of B. What do you think this will end up to be? This is some basic limits people need to understand. And surprisingly, this question is on the BC test, and there's some people still screw up. And I talked about it last year, and I talked about it this year. So this is actually one of the test question. So, and it will be on your test, and people will screw up. So limit x approaches c on b. What do you guys think that is? No. Nice try though. I like that.
Isn't it just C?
That's wrong too. You guys got to think of graphically. That's how you think about those questions. Even though it's a simple question, you got to start learning how to think graphically. You got to understand graphically is one way to approach math. So a lot of you guys can do algebra, great. But a lot of you guys are not good at algebra yet. So if you're not good at algebra, you're probably going to get 2 on AP exam. But if you understand how to look at things graphically, it can give you 1 additional point. So you'll get probably AP exam 3. Now, if you guys are good at algebra, then you probably get a 3. And if you got additional point, it's going to be graphically, it's going to be a 4. Now, how do you get a 5? It's a people can think analytically. Analytically is deciding what to do when to do what, sorry. For example, you can look at it numerically, you can look at graphically, you think about algebraically, and you know when's the best time to use what. So I want you to think about graphically what happened here. And I believe there's only one person can answer these questions here. What happened when limit x approach c on b? I'm going to tell you c and b both are constant, just different constant. Nope. Good try though.
It's not C, right?
Ethan?
It wouldn't be A.
No, there's no A.
I think I see A, B, C. You're
Nope.
Doesn't exist.
Nope. I like you guys like saying confidently. No, it's okay. It's okay to get it wrong. You're supposed to get it wrong.
Wait, does not exist, right? Because it's
Nope.
not guaranteed.
It's guaranteed value.
It's a limit.
Wait,
Is it B? Like does
B is correct. But do you know why it's B?
like it just clicked for me. I was like, wait a minute.
I think so. I can see it, but I don't know how to explain it.
Okay, so Ethan says he can explain it. So how would you explain it, Ethan?
Because if you replace B with f of x equals B, which would be a constant, so that would mean y equals 1, for example. So at any moment, it's always equals 1. So the limit would always be
Exactly. So I knew Ethan would be
I would just thought
one of the person that come up with this, and Rajas is coming close, but he didn't know how to explain it. So f of x, this is usually a functions, right? And f of x usually is a y, right? So that means y equal to b. So y equal to b, that means I'm going to graph a function y equal to b. B is a number. It could be anything. So we're going to say it's 1.5 here, b is 1.5 here. And so y equal to b. So if I approach some type of c value, my output, it doesn't matter where my c is. It doesn't matter where my c is. My answer is always going to get b.
It's still the same graph.
It's still on the same graph. So the next basic graph is this. Limit x approach c, but instead of constant, I'm going to give you a variable. So limit x approach c on x.
This one would be C, no? Or it still doesn't work. Since X is now a variable to the graph, and the C stay the same.
So what do you think this is?
X isn't constant.
X is a variable.
equal x, right?
But C is still constant.
C is still constant.
So it's just
A, B, C is constant. X, Y, Z is a variable. That's why I think of easy. The math is so weird. And L and K is actually a constant, so we're gonna talk about it in a second. I don't know why they use L. I think I know why they use L. Nope. Nope. Nice try. It's okay to be wrong right now. 42. A long time ago, people used to say 21.
Wait, is it wait? No.
You never heard 21? Did you ever see that meme of 21? A long time ago. Let's get 20 years ago.
See?
Huh?
C is wrong, right?
C is right.
Oh, I said C.
Okay.
Yeah,
C is
that
right.
was like the first thing on that.
Because if you look at a graph of x, right? This is a graph of x. If you guys don't know what a graph of x looks like, graph of x looks like this. And the cool thing about x is this. It didn't matter what C here, the output is going to be C because you basically plug in. It doesn't matter C here, this is still C. This is C here because it's going to give you the same exact output, so the answer is C. So limit x approach C is equal to C. So graphic approach is very important, especially absolute value, especially like limits like this. Okay, so I'm gonna go back to talk about some properties. This is some property. Now, you probably don't need to write it down on all of them. I only need you to understand the first one. The first one is limit x approach C, and you realize that B is a constant. Now, they also tell you there's an f of x, there's a g of x, limit x approaches C of f of x equal to L, and L is another constant, K is another constant, and I cannot tell you why L and K is constant, because I feel like L is some type of limit approach to a constant. That's why they call it L. And I feel like the next letter they come up is K. So K is also another constant, but that L and K is a little bit different than A and B and C, just because this limit approaches something that equal to a certain value. And we're gonna call it L. You're gonna see that in the horizontal asymptote, you're gonna see that in things. So limit x approach C of g of x, we're gonna call it K. Now, if that's true, then we can take the B outside the limits. So we can become BL. So remember, constant, you can take it outside the limits. Expression, you cannot take it outside the limits. So if you have limit of x, you cannot take x in front of the limit. But if limit of 2x, you can take it a 2 in front of the limit. Does that make sense? A constant can be bring outside the limit, not the expression, not an x or y or z. Is that okay?
Can you repeat that?
Okay, so for example, limits x approach 2, right? 2x. Now, the 2 can take it outside, so it'll be 2 x approach to 2 of x. X cannot be outside the limit, but the 2 can. 2 is a constant. Any constant can be moved outside. Any variable has to stay inside the limit. Kevin, does that make sense? Okay, so those are the property of limits. They're not crazy, they are intuitive. It just, limit x approach C of f of x plus minus g of x is equal to L plus minus k, because a rich C is going to be L, if a rich C is going to be k, so it'll be L plus minus k. Limit x approach C of f of x times g of x is equal to L times k, which totally makes sense. L over k totally makes sense. Number 4, k cannot equal to 0, because denominator cannot equal to 0. Number 5, it's rich that it's going to be L to the n. They are very intuitive. They just think of every time they look at this. So instead of limit x approach C of f of x, that's always going to be L. Now, this is a property of limits, nothing crazy. So we're going to talk about finding limits algebraically. Okay, let's talk about finding limit algebraically. We already did finding limit graphically today, but we're gonna find the limit algebraically. Okay, so first about the first step, you're gonna always plug in the number. If you limit x approach 2, plug in 2 for x. So plug in the number, and if you get a number, that means you're done. So that situation look like this. When limit x approach to 3 of 3x plus 2, what do? You plug in the 3. Unfortunately, I'll never ask this question, but this is algebra 1 question. Plug in a number. But like I said, unfortunately, I'll never ask this one because all you guys can do it. What I would ask is this. If you plug in a number and then you get first situation, 0 over 0. We already know from yesterday, 0 over 0 is not undefined. It's not 0. What is it called? Indeterminate. Now, only the indeterminate is 0 over 0. There's actually 6 different forms. There is infinity minus infinity. Okay. 0 over 0, indeterminate. Now, when it's 0 over 0, that means you have to do math. It's crazy as sound, just do math. Well, many different kind of math. First kind of math is called, you can factor everything and cancel. Hopefully something will cancel out. And then plug in the value. Right? 2. If you see a radical, you should think about conjugate. I don't know if you know what does conjugate mean. It's not in Spanish. I know some of you guys are thinking Spanish. But math conjugate is a little bit different. It's used the idea of a difference of a square. 3. You can do complex fractions. If you see a complex fractions, usually just combine fractions. It's called combine fractions. And we're going to talk about that. 4. You're going to see a absolute value. And you got to think about one side limits. And the piecewise function. Okay, so you might think about those things here. So you're gonna have possible things here. So let's give you a first thing. Let's start with something that a lot of you guys don't remember, but I put on the test. It's limit x approach 2 about x cubed minus 8 over 2 minus x. I'm going to teach you some algebra, which is right now in pre-calculus class, we are talking about this. Their homework has question like this. So any of my pre-calculus should be able to do it, but some of you guys cannot because you guys don't remember how to factor the cube. It's called difference of the cube. Do you remember how to factor difference of the cube? SOAP. Good. What is SOAP? A to the cube minus b to the cube or plus b to the cube equal to same. That means the sign is same. And O means opposite and then positive, right? So it'll be a squared, ab, b squared. Or a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So how do I factor the top? Before I factor the top, what am I going to do? I'm always plugging the value. So it's gonna give you a 0 over 0. Before I do anything, I plug in 0 over 0. Wait, Kelly, how much time I have? Okay. And what I'm gonna do is I'm gonna factor this. So if I factor this, it's gonna be, I figure out what an x cubed equal to a to the cube, b cubed is equal to 8, x must be x, b must be 2. So that's gonna be x minus 2, x squared plus 2x plus 4. Does that make sense? Over 2 minus x. Now, can x minus 2 and 2 minus x cancel?
Yeah.
Yes?
Yes.
No, like,
I don't think so.
Technically, no.
Oh,
You had to do something before you can cancel. So technically, you want to say limit x approach 0 of x minus 2 times x squared plus 2x plus 4. In order to cancel, you had to factor out a negative sign. And that's something that you guys need to know. This now, you can cancel this. And if you cancel this, it's going to be limit x approach to, whoop, it's not 2. This is 2. This is 2. 2. So now I'm going to plug in. So it'll be plug in 2. So 2 squared plus 2 times 2 plus 4. That's equal to negative 12. Because this negative sign is going to affect everything afterwards. And that's why you need to factor out a negative sign before you cancel if they are different order. There's some algebra tricks that you guys are supposed to remember. So I'm going to use right now to talk about those algebra tricks. The second case is, so you have to know all the factoring technique. Could be difference of square, could be sum and factor by grouping, could be all other things. But right now I'm going to talk about the next situation. So we're going to talk about situation 2. When limits x approach 0, and the x plus 1 minus 1 over x. What happens if you plug in 0? Not undefined.
It would be
It'll be 0 over 0. So when it's 0 over 0, it means it do math. What kind of math? When we see radical, what do we do? What is conjugate, by the way?
now you get the difference.
Kind of. But you never had to rationalize numerator before, but this is the first time you rationalize numerator. But that's okay. You can rationalize numerator. So what is a conjugate? It's not flip. Opposite sign of the radical. Does that make sense? Is that okay? That's called conjugate. So look at the conjugate. Look at this as a minus b, right? You wanted to have a plus b. Because nice thing about a plus b times a minus b is equal to what? And that's the reason why we do that. Because if I do that, that's going to be limits as x approach to 0 of square root of x plus 1 square minus 1 square over x times square root x plus 1 plus 1. That looks like very crazy. But I promise you it's not as bad as it seems. That's equal to limit x approach 0. That is going to be x plus 1 because x plus 1 squared is going to be x plus 1 minus 1 over x times square root of x plus 1 plus 1. Am I going too fast? I just knowing the numerator is going to be a squared minus b squared. Now what's thing is this going to simplify down. So left with limits x approach 0 of x over x times square root x plus 1 plus 1.
You can cancel the x's.
You can cancel the x's. Good. The x is going to cancel out. Left the 1. Please always put a 1 on the top. If you cancel, sometimes could be -1. Now I'm going to approach 0, so I'm going to plug in the 0. Square root of 0 plus 1 plus 1. So be equal to 1 over square root 1 plus 1 equal to 1 over 2. My answer is 1 over 2. How many of you guys are confused what I did? Raise your hand if you're confused. Yes, madam.
You go over
The numerator. Okay, I'm gonna show you how to do it slowly, but I don't want to do it slowly because that take too long. So that's called conjugate, by the way. If I distribute this, I'm gonna get x plus 1, right? If I distribute this, it's gonna be plus x plus 1. If I distribute this, it's gonna be minus square root x plus 1. If I distribute here, it's gonna be minus 1. Those two cancel. It's gonna be x plus 1 minus 1 equal to x. So I just do it shorthand because I know the difference of the square. I'll see you guys next time.